Let's take a second to read the problem if you haven't done so already. And we can start right with part A. What price gives the greatest income? So here's something I think we can all agree on. The income is going to be the price per ticket times the number of tickets that we sell. You sell 500 tickets at $10 a pop, you've got $5,000 for income. So let's find out an equation for the income. First, the price is a variable because they say right now it's set at $8, but it could go up $1, it could go down $1. So let's put that in algebraic notation. So there's the price with some algebra. It started at $8, but we might increase it by $1 or $2 or $3. So that's where my variable x came from. X represents the number of times we increase the price by $1. Okay, so let's do the same thing with the number of tickets sold. That again depends on x, the number of times we increase the price by $1. If we increase the price by $1, we sell 20 fewer tickets. So let's start off. We start off with 300, and we're going to subtract 20x from it, because if the ticket price goes up $1, we lose 20 people. If it goes up $2, we lose 2 times 20, makes 40 people. If it goes up $3, blah, 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 it keeps changing like that. And x could be negative. X could be negative, which means we decrease the price by $1, and therefore we'd get 20 more people. So this is an equation that represents the income. We want to maximize it. And you should be able to, recognize that the equation is a quadratic, because if you multiply these two binomials, first do 8 times 300, then we do 8 times negative 20x, 8 times 300 was 2400, 8 times that makes negative 660x, then 1x times 300 makes a positive 300x, and they got 1x times negative 20x. Makes negative 20x squared. So there it is. It's a quadratic because the highest power is x squared, and there's no numbers there's no variables to negative powers. So it doesn't quite look like a regular quadratic. Let's put it in standard form. The x squared term is supposed to come first, so we're going to put that out front. Then we can combine like terms here, then plus the 2,400 there at the end. So it's important to remember that this is still the equation for the income. We were asked for the price that gives the greatest income, so we want to maximize income. So we want to maximize this quadratic. And because a is negative, meaning the number in front of x squared is negative, we know it's going to look something like this, a parabola that reaches a peak. So if we can just find that vertex, we'll find the maximum. Here's how we find a vertex. The x-coordinate of the vertex is the negative b in standard form divided by 2a. So it goes a, b, c. That means we're going to be doing negative 140 divided by 2 times negative 20. And when you simplify that, you get positive 3.5. So we've got the answer to part A. What price gives the greatest income? Remember, this represented our price. We just found out that x is 3.5, so 8 plus 1 times 3.5 is 11.5. That's the price we should be selling these tickets at. And then part B, what's the maximum revenue? You can find that by plugging in the price that gives you the maximum income. So plug in 11.50 back into your income equation. So here's our income equation. So everywhere where we see an x, we're going to put in that max price. So I plugged in the ticket price we found that would give us the maximum income into the income equation. And now we just got to do the order of operations carefully to get down to the final answer. 11.5 squared. Then we've got 140 times 11.5. So the rest is just doing multiplication first. Multiply these, then you get to add everything up. And when you do that, you should get 2, 6, 4, 5. That's the maximum income. According to those pieces of information they gave us, that's the maximum income we can expect. So that's our answer for part B.